Is that a yes? No? Maybe? We'll say yes. Go for it. So, good afternoon. Today's Tuesday, day 2 of Tech Ed. This is my second presentation of the day. After this, I get to go have dinner and relax a little bit. I'll be at the booth for the rest of the week, but luckily this is my last presentation, so I can relax a little bit. My name is David Robinson. I'm a Senior Lead Program Manager on the SQL Azure team. Today we'll be talking about SQL Azure Advanced Administration, backup restore strategies, and just overall database management of the system. We only have, at last count, about 28 people in here, which is actually could be a good thing, could be a bad thing. The reason I think of it as a good thing is that we can be much more interactive, with such a small group of people than we would be able to, if there was, the room was packed. So as I'm going through these different slides and we're talking about the different technologies, feel free to stop me. This is all about you guys. It's all about me helping you understand these topics. So if you want to go deeper in one area, if I'm not making myself very clear, go ahead, just say, raise the hand, shout my name, say, Dave, stop, whatever you guys want, it's all about you. Today's agenda, first we're going to do a quick review of the current state of SQL Azure. We'll talk about, basically what it is, get everybody up to speed for those of you that may not be familiar with Microsoft's cloud database. We'll then talk about the different ways for provisioning servers and databases, both programmatically and also using some of the tooling support that we have inside the various Microsoft tools. We'll then talk about how to install and migrate databases. This is a topic that comes up a lot. How do I go ahead and get all my stuff up there? What are some of the strategies I can use? What about if it's a very large database? How do I go ahead and do that? And then we'll talk about throttling. Throttling is one of the things that people want to know most about. Exactly what it is, what triggers throttling, and how you can go ahead and really have a resilient application that can get around any of the multi-tenancy throttling that's built into the system. We'll then very quickly talk a little bit about tuning your database. I say very quickly, it's more of a, hey, let me just show you some quick queries about how we can see some of the worst performing queries inside the system. It's going to be really quick because everything that works for the most part in SQL Server from a DMV perspective continues to work inside SQL Azure. So all the knowledge that you have from a SQL Server perspective just applies. So you can just go ahead and follow the same patterns in SQL Azure. We'll then talk about all the different mechanisms that we have for making copies and backups and restores and importing and exporting databases in the system as well. There's many different options, and those different options, they all have their benefits and weaknesses, and they all have their specific use cases. So we'll cover that, and then we'll also talk very quickly about the different platform investments and kind of what we're working on the platform in this current calendar year. So before we begin, who's familiar with SQL Azure? Good, a bunch of you. That's promising. Who's not familiar with SQL Azure or SQL Server? Nobody. That's even better. Perfect. So let's move forward. I'm going to go quickly through these slides just because I don't want to bore the majority of you, but we'll still talk to them. SQL Azure is Microsoft's cloud database. It's based upon the SQL Server 2008 R2 engine. The same engine, the same query processor that's available inside the box is up in the cloud. We have, however, made some changes to the engine. We've made changes from a replication, a fault tolerance, and availability perspective. Inside the system, when you get exposed to an actual database, behind the scenes there's actually 3 copies of that database. We have a primary replica and 2 secondary replicas. So what happens when you go ahead and you connect to a database, we have these machines called gateways, and the gateway machine maintains a metadata directory. Inside that metadata, it says your database is located on this node, and it goes ahead and routes you accordingly to the back-end node, which is hosting your database. SQL Azure is a multi-tenant system, which means that your databases will live on boxes with other people's databases. That's where things like throttling come into play, and we'll talk about that later on in the presentation. We use the same tools and same frameworks, same everything. So you'll see in a little while that we'll actually use SQL Server Management Studio just as you would with an on-premise database. Today we have 6 global data centers, 2 in the US, 2 in Europe, 2 in Asia. We have more data centers planned. I can't share with you currently where those locations are, but there's definitely more data centers coming online. And the great thing about the system is high availability and redundancy is built into it. So if something should happen to your primary replica, behind the scenes we'll do a failover, and either your secondary, or excuse me, one of your secondaries will be promoted to primary, and things will go on as normal. Things like racking machines and installing software, all the benefits of cloud computing, all applies within SQL Azure as well.
Yeah, I have a question. Can you go down drill a little deeper on that? I'm just trying to get my head around this. Is there
Sure.
like 2 code bases here, or is Azure just a specialization and an implementation of SQL? I mean, I'm just thinking, isn't your SQL good enough that you can just use it? Why do you need this extra layer? Now we're going to have 2 code bases going forward, forking off, and
so is the question, are there 2 separate code bases inside the SQL product?
Right.
Yeah. So today, or actually, if we back up a couple months ago, there were actually 2 separate code bases. There was one code base that we were servicing for the SQL Server on-premise product, and there was a code base that we were servicing for the SQL Azure product. The changes that we had to make to SQL Server.exe was from a multi-tenant standpoint to ensure that your database was not able to see any of the data from the other databases that were residing on the same node as you. On the team, it was very expensive for us to go ahead and maintain 2 separate code bases. We would always find ourselves in all these merge situations where R2 came out and we had to go ahead and take all the changes from R2 and integrate them back into the SQL Azure base. A lot of tax on the team. We've actually spent the last year working on merging those 2 code bases together. And what you'll see as we talk about later on in the deck, when we talk about the investments and what's coming in some of the latest service releases, we'll actually start to begin with the next service release. We'll actually be shipping out of a common code base. And the SQL Server codenamed Denali query processor and engine will actually light up inside SQL Azure in the next couple months, actually. So it's good stuff. From an engineering perspective, there was a time that it made sense to have these 2 separate code bases when we were running really, really fast to get the service out. But now that the service is up there and we have broad adoption, it really makes sense to, just from an efficiency standpoint, to have those 2 bases together. Great question, though. So comparing SQL Server and SQL Azure, the goal was always symmetry. We always said that the same T-SQL that you used with your on-premise database should always work in the cloud. There are some variations, though. And when we say variations, for instance, the create database statement. When you do a create database in the cloud, you just specify create database, the database name, you specify the max size of the database, and you're done. The T-SQL create database for the on-premise product is slightly different, where you have to specify the data file and the log file, the fill factor, the growth rate, things of that nature. The reason we don't need to do it with SQL Azure is that it's part of the service, takes care of all those things for you. So when we think about the T-SQL syntax that differs between SQL Server and SQL Azure, it really falls into 2 separate buckets. It's either A, T-SQL that doesn't make sense in the cloud, or B, features that we just haven't enabled yet inside the public cloud, SQL Azure. There are some variations that exist. For instance, table design. You need to have a clustered index on every single table within SQL Azure. We actually use these clustered indexes in our replication technology, so that's something that we need to have. We talked about some variations in T-SQL. And once again, there's some features that aren't there yet, and we'll talk about those features on the next slide. Scale strategy, that's a little bit differently as well. With the cloud, we don't have the ability to go ahead and just throw bigger and bigger machines at different workloads. So with the cloud, you really need to think about employing a scale-out strategy versus a scale-up strategy. All the differences and the overview can be found at that following link. And once again, as we go ahead and make more investments in the platform, over time you'll see the feature set become less and less different. And now that we are in a common code base, Instead of having engineers worrying about, okay, let me go ahead and take these features and integrate them into this code base, we're able to go ahead and really innovate much, much quicker on the product. So variations of SQL Server, we talked a little bit about it. Today it's based upon 2008. In the next service release, it will be based upon the Denali engine. We talked about the table design, that you have a requirement for a clustered index. No physical server configuration. All that stuff is handled for you automatically as part of the service. Some features are not yet available. Things like SQL Agent, full text search, Service Broker, CLR. That's not to say that they will never be enabled. So for instance, SQL CLR and full text search, behind backup and restore, those are the number 2 things that we hear from people all the time that they want. And that's something that we're actively working on providing for you. I can't commit to a time frame, but it's definitely something that you will have in the future on SQL Azure. When we think about connection handling, this is some interesting things we need to consider. When your database is running locally, you're going to see anywhere between a 5, 6, 7 millisecond time to go from your machine over to the database. It's pretty quick. When you're working with a cloud database, you could see latency starting upwards of 50 milliseconds all the way up to a couple of 100 milliseconds. So that really affects things like how your application performs and really how you need to architect your application. We've given lots of different talks around architecting your applications for the cloud. I'm not going to go into too much of that here. If you want to stop by the booth and get some recommended strategies for that, we can. But that's really not the purpose of this talk. We have load balancing built into the system. So we talked about how we have a multi-tenant system. Your database is living on a machine with other databases. We proactively monitor the performance of each one of the nodes inside the system. If we notice a single node is starting to get hot, we will load balance the databases on those boxes. And the way we do this is first we will do something called a swap. And how the swap works is, if you recall, we said we had a primary and multiple secondaries. We'll look at the 2 secondaries and we'll see which one of these is on a box that's being less utilized. So we'll then go ahead and do a swap and make that one the primary and make the primary that's hot the secondary. After we do that, if we notice that that database is still hot, we'll go ahead and physically create another replica on another box, and once that replica has been created, we'll go ahead and make that primary and then kill one of the other secondaries, just so we maintain the 3 copies that we guarantee. Something to be aware of. So we're going to talk about throttling in a little bit, about specifically what causes throttling. And for those of you, and I know one of our MVPs, Scott, is in the back of the room, when we first came out with the service 2 years ago, we throttled people like crazy. We were like the paranoid parent, that wouldn't let their kid drive, they wouldn't let them go out to the mall, none of that stuff. If somebody started using anywhere near too many resources, we were like, stop. But over time, we relaxed that. And so you'll find yourself, being much less throttled than you would have been 2 years ago. We talked about database scaling. For those of you that are not aware, SQL Azure today is constrained to a 50 gigabyte database. We are going to be going ahead and increasing that size, and it will be increasing over time as well. But that's something for you to think about. So when you think about the different types of workloads and the different types of applications you want to go ahead and target with SQL Azure, that's something to keep in mind. There's no concept in the cloud, as far as scaling up. It's all about scaling out. There's a question in the middle. What are we, or what are you going to? Yeah. That's a great question. So it's basically, what happens if I start today and I have a 20 gig database, and all of a sudden, my application becomes super, popular, and it grows to 50, what happens? When your database hits the 50 gigabyte limit, the system will not allow you to write data to that database until it drops below the 50 gigabyte limit. It's something to keep in mind. I don't know if I would want to play chicken with us saying that we're going to go ahead and increase the database size. So if you don't have a good read on what your database growth projections are, then I would seriously think about that. The other thing I would think about is we've been talking a lot this week about support for this new feature called SQL Azure Federations. SQL Azure Federations enables you to scale out your database transparently. It requires very small changes to your application, but what it enables you to do is start with a single database, type in a split command, and it'll actually go ahead under the covers, partition that, and split that into 2 physical databases, and still treat it as a logical database. So that's going to be in CTP very shortly. We can get you signed up for that if you stop by the booth. The program manager working on that, his name is Jihan. I'm not sure if he's there today, but I can definitely put you in contact with him. Further info for some first-hand knowledge on what it was like to port Team Foundation Server over to the cloud. There's a blog by Brian Harry it's a really interesting read on some of the things that they faced when they were going ahead and migrating. Just really quickly, because this is a pretty busy slide, we made a lot of progress in 2010. Everything from additional T-SQL support to increasing the database size from 10 to 50 gigs, adding support for spatial data, Mars, database copy, some more quality of service enhancements, the new Windows Azure portal, the data sync service, which enables you to go ahead and synchronize cloud-to-cloud database or SQL Server to cloud database. Went into CTP1. CTP2 came out in Q4. We also had a CTP of reporting services as well come out this year. So enough about that, and just let's move forward. So if you need to provision a server in a database, you basically have 2 options. From a server perspective, you have option number 1 to go ahead and use the Windows Azure Platform portal. If we jump for a second and actually look at the portal, we can see what that actually looks like. So for those of you that are familiar with SQL Azure, this should be pretty familiar to you. This is where I'm in the SQL Azure section of the portal. Up at the top, I have a ribbon with all the different actions I can go ahead and perform on my server. I have some getting started and some tutorials. And then over here, I have a listing of all my different subscriptions. So for those of you that were not at my earlier session, on Monday we actually announced the ability for you to have multiple servers per subscription. So before Monday, there was a tight tie between the subscription and the server. If you had a subscription, you were only able to create a single server on that. That posed lots of different challenges for people. Challenges both from a billing perspective. Maintaining all these multiple subscriptions, which wasn't the most elegant thing to do. Things from a database lifecycle perspective. People wanting to go ahead and say, I have this server, this is my development environment, I want one for my QA environment, I want one for my user acceptance testing, one for production. So we've enabled you to go ahead and create multiple servers per subscription. So very quickly, if I wanted to go ahead and create a new server, I would just click on one of the subscriptions I have. And we could see basic information here about my subscription ID, who the administrator is. And I can go ahead and just simply click Create. And it pops up with a wizard that's going to walk me through the steps. Now, the first thing I need to do is select where I want this server to be located. So in this case, since we're in Atlanta, I'm going to choose the South Central US Data Center. Just very quickly, I'm going to go ahead and click Next. I'm going to put in my login, which is always David Robb with pass@word1. There we go. I'm going to go ahead and click Next. With the new portal, in this wizard, we've given you the ability to create your firewall rules as you're creating the server. This was a big pain point for customers beforehand. We would give you the ability to create a server, but we weren't very explicit around the need to say, hey, before you can go ahead and access that server, you need to go ahead and open it up from a firewall perspective. The SQL Azure Firewall will prevent any access to your database until you go ahead and open this up. So I can just go ahead and very quickly add a rule, call it the internet, and just we go. It gives me my source IP address if I just wanted to open it up just for this one IP. And then when I go ahead and click Finish, it's going to go ahead and provision that server, and I can go ahead and start to create databases on that server as well. So that's option number one, using the portal. This is great for, if I'm a hobbyist or if I just want to go ahead and play, I'm not from a very large organization. It all works. The problem is that, most IT departments, they want to be able to script everything. They want a programmatic way to go ahead and do this. So in the May service release that just came out on Monday, we're providing you something called the programmatic API for doing these actions over a REST interface. So in order to do that, you need to do a couple things first. The first thing you need to do is to upload an X509 certificate to the portal. Now, if you're using Windows Azure and SQL Azure, that cert is shared across the platform. So if I click on Manage Certificates and have this thing load up, I can see I've previously gone ahead and loaded up. I actually have two certificates. One is actually, this one up here is for the demo. This one down here is actually for some management stuff that we do internally from a testing perspective. So I've gone ahead and I've uploaded the certificate. And now what I'm able to do is I'm able to jump out into Visual Studio. And I can use pretty much any tool that can send an XML payload to an HTTP endpoint you can use. But Visual Studio, obviously, we're from Microsoft, so it's the preferred tool. I have a couple things specified up here. I have my subscription ID, which we saw within the portal when we were in there before. This is the unique identifier for my subscription. I have a path out to my certificates. I'm specifying the same things I specified in the wizard. I'm saying I want my admin name to be this. I want to create it in South Central US. And we'll talk about these four guys in a second. So if I very quickly go ahead and uncomment these lines and open this up and just take a look at what it's going to do. So basically, what it's going to do is it's going to assemble an XML payload, and it's going to do a post to this endpoint, management.database.windows.net. And if I go ahead and run this, it's going ahead and creating a new server, and in a second it'll actually show you the payload, and there it is. And then in a second it'll come back to me and tell me that my server's been created. So it's created me a new server, and this is the server name right here. So as we saw before, until I go ahead and open this up from a firewall perspective, there's nothing I can do with this. So if I simply go ahead and edit this, and let me just go copy the server name out, and then kill that. And let me close this and come back up here and paste that into my server name. Perfect. And now I let me open this guy up, comment that, and take a look at this. The same pattern that I followed before where I just assembled a payload, and I did in this case I'm actually doing a put to this endpoint. This will go ahead and create the firewall rule for me programmatically. And let me just go ahead and run that. Give it a moment. And then it's gone ahead and created, over REST, over HTTP, it's gone ahead and created me that firewall rule. So this is a great way for you to let's say you're an ISV and you're provisioning your software package for many, many different customers, great way to do it. If you're an IT department and you have a lot of people asking for different servers, another great way to do it. We have customers that are actually building self-service type workflows within SharePoint to be able to very quickly go ahead and have people provision SQL Azure servers using these methods as well. So that's the two ways of going ahead and doing that. Come on. There we go, that's better. So the platform portal, like we said, really easy and clean. No programmatic support, but the server API with the certificate that we had previously uploaded secures the channel via mutual client authentication. The same certificate as Windows Azure APIs use, and it provides a lot of flexibility for your staff. So we already did that demo, so let's just go ahead and continue. What about installing and migrating databases? We got a lot of feedback from people, and that's one of the big questions is, how do I get my stuff up there? I want to use it, but I have a 20 gig database, and what approach do I use? There's multiple different options. So number one is scripts. You can go ahead into SQL Server Management Studio, and you can go into the Generate Script Wizard, and you could specify the engine type of SQL Azure, and it'll go ahead and generate a nice big text file for you that you can go ahead and run against the cloud. That's great if you have a 1 megabyte database, a 2 meg database. If you have anything of any substance, that's going to take forever to run. It's really not a great use of anybody's time or resources to run a 20 gigabyte script against the system. Another option is something called a DAC pack. Inside Visual Studio 2010 and SQL Server 2008 R2, we introduced a new project type and a new framework. The DAC pack is based upon the Data Tier Application Framework. It's also a new project type inside Visual Studio. And it's a great way to go ahead and package up an entire database. Now, the gotcha with a DAC pack is it's just the database schema itself. It does not include data. So depending on where you are and where you are in the life cycle of your database, a DAC pack may or may not work out for you. One thing to point out, though, is let's say today I'm working on V1 of my application, and I go ahead and I deploy it to the cloud. My application's hitting it. It's loading up all sorts of different data. Life is great. And I want to go ahead and come out with version 2 of the application. Even with data inside that database, DAC pack does provide support for upgrades. So I can go ahead and make my changes to my data tier application, go ahead and upgrade that database up in the cloud. It'll go ahead and generate all the diff scripts for me, and it'll also migrate all of my data. So it's a great way from a project management and from a development standpoint to save yourselves a lot of the heavy lifting of, okay, this is version 1 of the database, let me go ahead and figure out how I can go ahead and get that to version 2. The other great way to do this is something called a backpack. A backpack is basically a DAC pack plus data. It's in CTP today. If you want to try this out for yourself, it's available on www.sqlazurelabs.com. So basically, it's just an extension to the Data Tier Application Framework that includes support for exporting the database and including all the data inside there. So today, it's a command line only tool. In the future, in the next service release, we're actually adding this to the Windows Azure Platform Portal. So that way, if you go ahead and do an export from a local SQL Server database, you can upload your backpack to there and restore it right from the cloud to your database. It's also scriptable via PowerShell as well. So if we just jump out with just one more quick demo and just look to see how easy that would be. If I open up a command prompt and change over to my TechEd directory, where all my stuff is, and I have some sample commands here. So let's take a look at this. So what this is saying, go ahead, connect to my local SQL Server instance on my laptop, connect to the AdventureWorks LT database, and go ahead and extract and export all the data, all the schema, all the objects, everything that I need to reconstitute this database, and save it as this AdventureWorks LT .backpack file. So as we can see, what it's doing now is it's gone ahead and connected to the database. It's going ahead right now, it's looking at all the different objects in the database and coming up with a big manifest file of everything inside that database. And in a moment, what it's going to start to do is it's going to start going table by table, object by object, pulling everything out and saving it in this backpack file. So that's great. So I've now taken I now have an artifact of my entire database from SQL Server on-premise that I can go ahead and do lots of different things with. Number one, this is just a zip file with JSON encoded data. If I wanted to, I can actually crack this file open and start to look at the data, make modifications to it if I wanted to. Or, for purposes of today's demo, and let me go ahead and actually import that into SQL Azure. And it's just another single command. If I go ahead and do edit paste, it's going ahead and taking that backpack file that I just had exported. It's connected to the cloud. And now it's going table by table, object by object, and moving it up into SQL Azure. So very easily, one command to get it from on-premise to a file, another command to get it from a file to the cloud. Now this is not just from on-premise to the cloud, but we have customers, and we'll talk about some of this when we get to the backup strategies part. We have customers that say, you know what, I understand you maintain multiple copies of my database. That's all fine and dandy. But when I go to sleep at night, I want a copy of this thing under my pillow. So you can very easily use this to take the database from SQL Azure and move it back on-prem or move it to just an artifact for you to go ahead and back up on your own premises. So that's the backpack. Easy way to go ahead and migrate databases to and from SQL Server or SQL Azure. So now the topic everybody's been waiting for, throttling. So let's start with why we have throttling. Throttling is really there to make sure that we provide a good experience to all databases on a single node. It's like we always use this analogy around the airplane. When you're flying on a commercial jet, you're guaranteed a seat on that airplane, but you're not guaranteed that there's not going to be somebody sitting next to you that may have some bad BO. And it's if the person next to you on an airplane starts screaming, the stewardess is going to come by and they're going to settle that person down. They're going to make sure that you get guaranteed a good experience on the airplane. And throttling works the same way. SQL Azure is able to quickly monitor and rebalance databases automatically. And we talked about earlier about how it does the swap versus move and things like that. But throttling, if you go ahead and you start utilizing every single resource on that box, the system will throttle you. And the next slide will actually go ahead and talk about what will trigger throttling and what those thresholds are. One other thing to point out, and we'll talk about this a little bit more when we get to the investment slide, we are working on something called resource reservation. Resource reservation will allow you to specify, hey, I want this set amount of resources allocated to my database at all times. So I have more predictable performance of my database. So until that comes out, we need to think about how we can go ahead and deal with throttling. This slide I suggest everybody download, print it out, put it up on your wall, and it basically goes into the details on what specifically causes throttling. And we have a bunch of different things that will trigger this. Number one, lock consumptions. If you have a single session inside the database and it's using greater than 1 million locks, we will throttle you. Okay? I don't mean to sound like Mr. Negative. I'm just trying to keep it real, and so you guys have the knowledge and the background for what to expect. Now, keep in mind, 1 million locks is a lot. So it's not all that bad. Excessive log usage. If you have a single transaction consuming greater than a gig of the log, you'll be throttled as well. That log file is super important to us for us to be able to go ahead and back that thing up. Once again, it's all about keeping the system up and making sure that we can we're resilient to failures and whatnot. Uncommitted transactions, same thing. If it's using greater than 20% of the log, you'll be throttled. Excessive temp DB usage. If you're using more than 5 gigabytes of temp DB, you'll be throttled. This one's a tricky one. Excessive memory usage. So in the system, we have these things called watchdogs, and its name, it was called a watchdog for a reason, And the watchdog will actually sit there and monitor the health of all the different nodes in the system. So if the watchdog notices that there's excessive memory usage on a box, it'll go ahead and it'll start with all sessions that are using greater than 16 meg of memory for 20 seconds. It'll start to terminate those in descending order until the memory contention on the box is alleviated. And then finally, idle connections. This is more from a less of a performance, keeping the box healthy, and more about a security mitigation. So if you have an idle connection that's idle for more than 30 minutes, that'll be terminated as well. We're very serious about security at Microsoft, obviously. And one of the things that, when we were doing some of the early testing, we would notice that people would connect to the system and they would stay connected for hours and hours and hours. And we quickly noticed that there were people doing these things for malicious purposes, where they would go ahead and connect and try to make sure that they were able to fill up all the entire TCP stack on our gateway machines with connections that are just sitting there idle. So we've actually implemented that idle connection killing. And back when we first went out with the service, we would actually kill connections after 5 minutes. But we realized, we talked about the paranoid parent. Maybe bedtime can go up to 10 o'clock versus 9 o'clock. So we've opened that up a little bit. So tuning your database, we're not going to go into too much details here because at its core, it's just SQL Server. So the same things that you can do from a database perspective to tune the database, from a query perspective or a store procedure perspective, all those things just apply. But the thing is that in the cloud, DBAs are even more important because you do have to deal with the constraints of a multi-tenant database. Who here in the room is a DBA? We got a couple. We love you guys. We need you guys. Everything that you've done on premise is even more important. So most of the DMVs that you're used to using today on prem, they continue to work. There are some additional SQL Azure specific DMVs which we provide. Things like DMVs for when I'm going to go ahead and I want to know how much space I'm using. What's the bandwidth I've consumed this month on the service? So additional ones like that. When we talk about the database copy a little later on, we'll actually show a DMV that'll show you where your database copy is in its life cycle and when it's about to complete. So the question was, will SQL Azure allow the use of Profiler? So today, Profiler does not work. For those of you in the room that we're all probably familiar with Profiler, Profiler is a very resource-intensive thing to run on a database. So today, no. What we are working on, and I can't commit to a time frame, is an X-events-based tracing mechanism, where you'll be able to walk up and you'll say, hey, I want to trace my database for this, at this period of time, and it'll give you a file you'll be able to download and actually analyze. So today, no, but something to fill that gap is definitely coming. Just a couple quick queries. Calculating the size of your database from DB partition stats. Pretty simple stuff. Monitoring connections. If you want to go ahead and see who's connected to your database, same thing. And then finally, find the top 5 queries. I put these things in there just so if you download the deck, you can just start to play with and understand. You know what? This is just SQL Server. There's nothing crazy about this. This is the same things I would do with my on-premise database. Excuse me. So, busy slide. Copies, backups, restores, imports, and exports. We have lots of different things that we've built into the system for providing different types of functionality. First thing that we provided was database copy. So we provided database copy in the Q3 service release. Might have been Q2. I think it was Q3 service release last year. And that was our stopgap measure. So everybody, when we first came out with the service, we said, hey, it's a cloud service. We'll do all the backups for you. And people came back to us and said, okay, that's great. You're doing all the backups. How can I do a restore? And we're like, yeah, we're not ready yet with the restore stuff. So we came out with something called database copy. What database copies enables you to do is to create an online copy of your database by simply typing in a single command. And we'll look at that command in a couple minutes. Today, it's limited to only a specific data center. So you can't do a copy from a server in perhaps a data center in north central US to a data center in the south central. But within the same data center, it all works great. It's great for creating an exact clone of an existing database. We see lots of customers using this for both backup purposes. We see people using this for testing purposes, depending on what your database lifecycle management facilities are within your company. A great way. We also have customers, ISVs, that'll have kind of like a template database. And when somebody goes out and buys a copy of their software, they'll just basically do a clone of that and then hand that off to the customer. You can actually do database copies between servers, between separate servers, as long as the administrator username between both is the same. Earlier today we talked about backup and restore. This was the #1 requested feature of SQL Azure. And to be clear, it's actually not backup and restore. It's actually just only restore. We've been doing backups of the systems ever since day one. Those backups were primarily for disaster recovery purposes. But we got a lot of feedback. It's very evident that people want the ability to go ahead and restore a database to a specific point in time. That specific window is, we'll give you, when the CTP comes out, we'll give you a 2-week window to say, hey, I want to go ahead and restore my database back to this specific point on this specific day. We also have import-export, which we talked about and we actually saw a little while ago. The ability to create a backpack, which is a backpack plus data. And it's really useful for moving stuff onto or off of the platform. One thing to keep in mind is a backpack is not a transactionally consistent copy of your database. It will go ahead and iterate table by table and do the extract. If something happens, and you have a foreign key, and something happens in one of the child tables after the parent table's already been backed up, you're not going to have a consistent database. So one way to work around this is we have customers that what they'll actually do is they'll go ahead and do a database copy, and then go ahead and do the extract from the copy, knowing that there's nobody connected to it. Import and export, like I said, it's really useful for going ahead and moving databases from and to the platform. The backup and restore is more for like an oops recovery type system, where if you accidentally drop a table, you truncate a table, you drop an entire database, gives you that capability to get that stuff back very easily. Let's actually go ahead and just take a quick look on how this backup restore will actually work when you get invited to the CTP. The first thing you'll notice is a little blue box at the bottom of your portal, same portal that we were looking at earlier, which will say, this server is now enabled for backup restore. Great. How do you go ahead and use it? First, we need to drop a database. So we have a drop dialog that comes up. You click drop and your database is gone. So what do? So you'll notice that there will be a new button inside the portal called Restore. Pretty self-explanatory. You go ahead and restore, and what it does is it provides you another wizard similar to the one that we followed when we were going ahead and doing the create server. And then it asks you for a bit of different pieces of information about the database. So the first thing it wants to ask you is, what database do you want to go ahead and restore? It'll actually provide, as we can see here, a list of all the databases that existed on that server and the times that they existed. So you simply go ahead and you say, I want to go ahead and restore this database. You specify a name that you want to go ahead and restore it to. And then you specify the specific point in time you want to restore that database to. When you go ahead and click OK, you'll notice that it will actually go ahead and add the database, and it'll have a state of restoring. And once that state goes to online, you'll be able to start to operate over that database. So that's the whole flow from how the point-in-time restore will go ahead and work. You cannot do that from Management Studio today. I can't really share any of the future plans on that, but we understand that doing the stuff directly from the portal, it may not be the best spot, We are looking into being able to provide you the ability to do this both with the on-premises tools and also via the same server API that we showed you a little earlier today. So that way you have multiple options. Another question over here? You can, the point-in-time restore, as long as the database name does not exist, you can restore to any database name you would like.
I don't have to go out to
No.
Okay, but I can take the backups of DB1.
And restore it to DB2. Correct. But to be honest, the amount of time it would take for you to do the backup restore, or excuse me, to do the restore, it would be much quicker for you to go ahead and just do a database copy. Because when you go ahead and you actually do the restore, we have to find the backup file, we have to find the log file, we need to restore the backup file, roll the log forward. It's, it's a timely operation. If you simply want a copy of DB1, you can use the db copy command, and that thing is online and it happens much, much quicker. And so actually, let's just jump out and actually take a look at what that will look like. So let me go to Management Studio. I'm already connected to my cloud database. I think I have a command somewhere. Here we go. Let me just copy all this stuff out. And let's take a look at what this looks like. So in order to do this, I need to be connected to master. Go ahead and just do a new query. Paste this in. And I've run this a couple times, so let me just go ahead and update that. So what I'm doing is I'm doing a create database statement, and I'm specifying the database name. In this case, it's pubs3. And I'm saying create database pubs3 as copy of pubs. So what it'll do is it'll kick off an operation to actually start building this database, online. And I can actually go ahead and I could take a look and see, hey, where is this database copy in its life cycle? I can also go ahead and take a look at sys databases, and I can actually see the state of the database as well. So as you can see, here's my pubs3. It's in the state description of copying. So right now, online is creating that copy of my database. This will happen much quicker than it would be to actually go ahead and do the restore of the database. Question over here? I think you had a sample first.
What size window do you have to be able to restore every 15 minutes?
It's down to the current GUI that we showed you has it specified down to the minute, but the actual restore can go down to I believe it's the second. I would have to follow up with the program. Henry, do you know, is it down to the second? Henry's not sure either. I can find out, but it's to a specific point in time. I've seen a change request go across the wire to modify that dialog to get more granular than the minute. So, but I believe it's the second. I could be wrong. There was a question over here.
There was a question there. It's more of a statement. What the lady was saying earlier is the common recovery scenario would be you've lost some data in a table,
Mm-hmm.
and so you want to recover a point in time to a second database, go and find the missing rows, and then put those back into your production database.
Mm-hmm.
So the scenario that you're talking about, you're less likely to use database copy. You're likely to
Correct.
use
Yeah.
storage.
Yeah. Absolutely. Yeah. It all depends on the use case. And somebody is IMing me. Let's go ahead and do not disturb. Sorry, Michael. Not sure what Michael wanted, but Michael's going to have to wait. So that's database copy. Let's actually go ahead now that we've been talking. And now the database is online for me to go ahead and use. So if it was just a matter of making a copy of a database, a great way. But yes, to the gentleman's points, if I had lost some data in a specific table, I could have used the point-in-time restore to go ahead and restore the database and then copied out the specific rows as well. So, how are we doing on time? Okay, we've got a couple minutes. So, where are we going with the service? What are the different things that we're working on? And, I'm going to talk for the next few minutes about the different investment themes that where we're investing inside the platform in this calendar year. And this is a great way for us to get feedback from you. As we go through the different themes and the different areas that we're investing in, I really want to hear your feedback on whether or not these are the important things to you. There was a lot of people in the room that are already familiar with SQL Azure, and it's really our job to ensure that we're giving you, the service that you guys require, and the features that are really going to, enable you to adopt the platform. So from a managed service perspective, things like data protection and recovery. So we've been investing heavily in this new point-in-time restore. We're also working on something called geo-disaster recovery. So today, if we were to, suffer a complete loss of a data center, God forbid there was an earthquake, it would take us, a bit of time to go ahead and take the backups that we have and get your services up and running in a second data center. So what Geo Disaster Recovery will enable you to do is actually go ahead and have a continuous copy going on from one data center to another. So that way, if we lost an entire data center, your data would not be gone, and you'd be able to get that back up and running, relatively quickly. Also, some new data movement capabilities. Big pain point, moving databases. We've made a lot of investments there. We're going ahead and lighting all those features up inside the Windows Azure portal as well as the migration tool support that we have for migrating from different databases. So today we can migrate from Microsoft Access, we can migrate from MySQL. We're also doing lots of work for Sybase as well. So you can go ahead and migrate your your database from Sybase using the SQL Server Migration Assistant up to the cloud. We're also working on enhanced management experiences. We've made a big investment in the Windows Azure Platform portal, and we're going to continue to invest there to light up new experiences around how you manage your data, how you manage your databases. Who is familiar with Database Manager or Project Houston that we came out with last year? A couple people. So what this tool is this is a Silverlight tool for doing basic database operations right from within the portal. That was only a first step in a very much longer journey in us really lining up much richer experiences within the portal. That way you don't have to worry about downloading 200 megs or a couple gigs of stuff onto somebody's laptop in order for them to go ahead and manage their cloud assets. It's a big thing to be able to have an entirely browser-based management tool or management experience. Now that's not to say we'll get there this year. These are just areas that we're investing in, but it's the general direction of where we're going from a management standpoint. Being able to scale out very easily. Things like federation support. To be able to have a single database, type in a command, and have that be split online. And once you've gone ahead and split that database, be able to take those two federation members and merge them back together. That's a really, really important feature and something we've been investing not only this year, but we invested heavily in last year as well. We got a lot of feedback from customers saying, you know what, even at 33 cents per day for a 1 gigabyte database, I need 10 meg. That's all I want, 10 megabytes. So, we're working on smaller databases as well. We talked a little bit about the performance predictability, the ability to say, hey, you know what, I want a certain amount of resources allocated to my database, and I want those guarantees. As well as enhanced multi-tenancy support. We showed earlier today the server API, and we're going to continue to go ahead and provide additional APIs for you to go ahead and manage both your servers and your databases as well. We talked about how we started off with 2 different code bases and how we were merging everything together, and it was going to be beauty once the next service release goes out, and we have everything on the SQL Server Denali code base. And, so once now that we're at that common code base, we can very much innovate much faster. We have the CTP of reporting as a service, and we'll be spending the rest of this year making sure that we're able to ship that to you this year as a credible service. We didn't talk about it today, but the data sync service as well, the ability to synchronize multiple databases, multiple cloud databases, and also from an on-premise database up to the cloud as well. That's another way that we have people that are actually using the cloud for a hot standby. So that way if something would happen to their on-premise database, they can simply just change the connection string and point to the cloud. We're investing in rich developer experiences. Tools like Project Juno. Project Juno is an amazing database development tool. Things like static code analysis, the ability to have a rich editor, hit F5, say I want to target SQL Azure, and have it say, hey, by the way, you're using a piece of T-SQL that's not compatible, and be able to warn you. As well as tools like Visual Studio Lightswitch. In the most recent CTP, full support for SQL Azure. If you're in a department and you're creating forms over data application, Lightswitch a great tool. We also announced with our May service release the support for a JDBC driver. So Java developers, rock on. You guys are ready with the driver. As well as some internationalization that we're doing from both the portal and from different error messages that the engine returns back to you. As well as data market. We really didn't talk too much about data market in this presentation, but data market is our premium marketplace for rich content. Data sets that would typically cost you, hundreds of thousands or millions of dollars, you're actually able to consume as a cloud service and only pay for the transactions that you go ahead and make against that database. So this is where we're spending our investment. Are we in the right areas? Are there things that you must have today that we're not working on? Got a hand? So the question was, is there going to be any support for integration services? So today, integration services does work. Inside R2, we've actually made some changes to the ADO.NET connection provider to enable faster uploads to SQL Azure by using the SQL bulk copy API. That's today. That's running it on-premise, connecting to the cloud. We are thinking about how we can enable SSIS in the cloud to go ahead and do your ETL jobs directly from within the cloud, not having to pull the stuff down. It's something that we're thinking about. I know the SSIS team is actively investigating these things, but I don't think it's something that's going to land anytime this calendar year. Those are,
So without the SQL agent, you need to run your own local engine in order to schedule remotely?
that is correct. So with the lack of SQL agent support today, you would have to run SQL agent locally, or you could do something where you use, up in Windows Azure, Windows Azure has many facilities for creating different types of what they call worker roles. And you could have a worker role that runs off of a queue that you can use to schedule jobs as well. It would require you writing some code, not difficult code, but it is code. So today, yes, no SQL agent, and your options are either A, run SQL agent locally, or go ahead and write some code as well.
Still be concerned about reindexing tables and fragmenting.
Absolutely. Yeah. When we say that DBAs are much more important now than they are on-premise, I'm serious about that, because you could take the worst performing application in the world, throw it at SQL Server on-premise, and as long as you have a beefy enough box, that thing it'll just take it and run with it. It's great. But keep in mind that SQL Azure uses commodity-based servers. So the amount of resources that you could possibly utilize on your database, they're limited. So it's a DBA's job to really make sure that people are making the best use of the database and that everything's properly tuned. And you're looking at the different DMVs, and you're looking at the database statistics to make sure that everything's performing as well as it could be. What about three-part DNS? So cross-database calls are not supported today. You can use three-part names as long as the three-part name references a database within the same, references a table within the same database. We don't support, so what happens when you go ahead and you physically connect to a SQL Azure database? We talked about how you have the gateway machine, and the gateway has the metadata. It physically routes you to a specific DB node where your database is. There's a high likelihood that the database that you wanted to go ahead and reference is on a completely separate node, on a separate scale unit, separate rack of machines. So it's difficult for us to go ahead and either do those types of queries or redirect those connections with the three-part names. That's the same reason that we currently today don't support the use statement as well. So there is an article. If you go out to the SQL Cat team blog, there's actually an article out there for how you can go ahead and use SQL Azure, not as the host of the link server, but you can actually, if you have an on-premise database, on-premise SQL server, and you want to add SQL Azure as a link server, going that direction works. And the article goes ahead and explains how you can go ahead and enable that as well. So let's just quickly go through the recap, and then we'll just do some more Q&A. So we talked about how you can provision servers and databases. We looked at the GUI. we went into Visual Studio, and we showed how we could do this programmatically. We talked about installing and migrating databases, how backpacks are truly the best experience and the best option for you. We talked about, what causes throttling. We talked about how, tuning a database, it's basically the same thing as SQL Server itself. We talked about the different options for copies, backups, and all things of that nature, and when, to use what. And then we also talked about the upcoming investments that we're making in the platform, and I was happy to hear, you guys feel that we're investing in the right areas. So with that being said, we have 13 minutes left. So anything you want to know, feel free to ask. Gentlemen. Uh-huh. So a couple things. The server management API and the database endpoint, those are hard-coded ports, obviously, 1433, 8443 for the management API. We do have certain customers that are running, proxies to get around that ability within their local network. But we don't today, and I don't think we will in the future, give people the ability to say, I want you to go ahead and listen on port 80, for instance. Now, that's not to say that there will never come a day where maybe we can route TDS over HTTP. That might be an option someday in the future, but for today, there's no changing of the ports. It's 1433 or 8443. Question over here? Mm-hmm. So the question is around separation of roles within SQL Azure. Great thing about SQL Azure, it uses the same security mechanisms as SQL Server from a role perspective. We only support SQL authentication, but you're able to create all the same roles and rights as you can within on-premise SQL Server. We don't have things like SQL Mail inside there, so no way to automatically send out emails. But you can go ahead and lock down specific user rights as you see fit. So that's an option for you. The backpack stuff it's an API, so you could easily write a PowerShell script to go ahead and wrap that and then send out email if somebody's upon successful export, successful import, things of that nature. Question there? Is there going to be a management portal? I think I can say this. Yes, I've seen it. It looks beautiful. That'll come out in the next CTP. I can't commit to when, but I've seen the portal, and it looks beautiful. Question over here? The backpack files are compressed. It's compressed JSON encoded data. And if you want, like I said, it's just a zip file. Crack it open, have a look. It's nice. Any other questions? All right, awesome. Thank you for coming.